Right. Right. In this problem, we have the theorem that S is equal to the set of vectors v1 through vn. And given that S is linearly dependent if and only if the vector equation c1 through vn, so this linear combination is equal to 0, has exactly a solution with at least one of the CIs. That's an I. CI not equal to 0. So in other words, there's at least one non-zero coefficient for this linear set. Okay. So this is an if and only if. So the proof of this means that we have to show both directions. Okay, so we're going to show the forward direction first. Okay, and so in this direction, what we're going to assume is that assume S is linearly independent. Okay, so if we assume S is linearly independent, then we say that we have a vector, at least one of these vectors. So at least one vector may be written as a linear combination of the vectors in S. Okay. Without loss of generality, we can assume v1 is that vector. Okay, so we don't know how many there are. It could be more than one, but we just need to know that one, since S is linearly independent. That's what we're assuming. Okay, so we assume v1 is linearly dependent. Okay, so that means that we have a vector v1 can be written as a linear combination of the vectors of S. So let's call it k1. Well, we'll call it k2 to keep the subscripts the same. K2 v2, k3 v3 plus k4 v4. Well, you get the idea. Plus dot 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 plus kn vn. Okay, so we can assume that this is true, since we are assuming that S is linearly dependent, and at least one of them, and so we can say that v1 is that one. Okay. All right. So if we can move this v1 over to here and say this equals to the 0 vector by adding the additive inverse of v. So we have this is true. Okay. And then if we write this as a linear combination from what we know about the set V, right, we also know that V1, C2, V2 plus dot 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 plus Cn Vn. Okay. So the only way that this is simultaneously true for both these linear combinations is if we can equate coefficients. And that means then that this implies then that C1 is equal to -1, which is not equal to 0, which is what we needed to show for the forward direction. Okay. All right. So let's then look at the opposite direction, going backwards. Okay. So in the backwards direction, here we're going this way. Okay. So in this direction, we want to show that given this linear combination C1 V1 plus C2 V2 plus dot 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 plus Cn Vn, okay, given this, we want to show that this set with supposing with some CI not equal to 0. Okay, so we're assuming this is true. We want to show some vector in S is, or maybe written as a linear combination. Okay, That's what we want to show now, going this backwards direction. So we're assuming that this is true, and we want to show that that results in a linear combination. So without loss of generality, we need just to, it could be one or more of these. So we're just going to say without loss of generality, let's say C1 is not equal to 0. Okay, so then we have V1, C1 plus C2, V2 plus dot 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 plus C to the n, V to the n is equal to 0. That was given. Okay. Since C1 is not equal to 0, we can divide each of these terms by that. Okay. And that allows us to write this as V1 plus C2 over C1, V2 plus dot 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 plus Cn C1 over Vn. Okay. Which then allows us to add the additive inverse of all of these terms over, which implies then that we have V1 is equal to C2, C1, V2 plus dot 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 plus negative Cn over C1, V to the n, which if you call each of those, let's say a constant K, K2, V2 plus dot 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 plus K n Vn, or I'm just making the substitution for each of the C's to represent that, okay? Then this shows that V1, so V1 is a linear combo. Okay. It's a linear combination of the vectors of S of the set S. Okay. So that's what we were hoping to show in the backwards direction, that given any at least one C1 not equal to 0, that means that that vector, we just chose it arbitrarily, means that it can be written as a linear combination. So that shows both directions, and I hope that was helpful. See you in the next video.